Welcome back. I'm here with Jimmy. He's playing his favorite game called Yellow Stick. And today, all right, Jimmy, today we are going to be talking about ratios some more and how to find equivalent ratios using multiplication and also division. If you remember, I said last time, and you've probably noticed by now, that ratios work almost identically to fractions. So my pencil. So if you remember those rules about fractions, they're the same for ratios. All right, we're in our workbooks, starting on page 265. And to begin with here, we have Sarah made baskets on some of her shots in a basketball game. If she continues to make baskets at the same rate, how many baskets will Sarah make in her next 6 shots? Okay, so let's take a look at how she's doing so far. So she has taken 18 shots and she's made 12 baskets. So one way to solve this is to make a table with equivalent ratios. And remember that if you want to find an equivalent ratio, if you divide both terms of the ratio by the same non-zero number, or if you multiply both terms of the ratio by the same non-zero number, you will find equivalence just like in fractions. Okay, so here they made a table. So number of shots taken and number of baskets made. And we know that we started here with 18 shots and 12 baskets. And then they divided both terms of the original ratio by the same number to find equivalent ratios. So first, they divided both of the terms, both of the numbers by 2, and then they got 9 to 6. Then they divided them both by 3, and they got 6 to 4. So Sarah will make 4 baskets in her next 6 shots. So do you see why they needed to do that? Because they wanted to predict the next 6 shots, and they only had data for 18 shots. So they had to divide to take it down to 6. Okay? And then here's another way of just using division. By what number do you need to divide 18 to get 6? Divide 12 by the same number. Doesn't that remind you of fractions? Right? Whatever you do to the numerator, you have to do to the denominator. It's the same concept. Okay, divide both terms by the same non-zero number. Sarah will make 4 baskets in her next 6 shots. Okay, say it with me. Try it. Rashida uses 8 cups of tomatoes and 3 cups of onions to make salsa. How many cups of onions should Rashida use if she uses only 4 cups of tomatoes? Okay, so the ratio is starting with 8 to 3. But now we want to go back, and that 8 is going to be a 4. So let's see what they did here. Which of the following ratios are equivalent? No, let's just work on this one. Okay, so if you have 8 to 3, or you might set it up this way, 8 to 3, and then you know the ratio you're looking for has a 4 here. What are you going to do? You're going to look at that 8 and say, okay, what did I do to that 8 to make it only 4? You divided it by 2. So if you divided this by 2, you're going to divide the second term of the ratio by 2 also, and you'll get 4 to 1.5, which is perfectly fine to write. Now, we wouldn't write a fraction that way, right? But even though it works like a fraction, it's not a fraction. So because it's a ratio, saying 4 to 1.5 is just fine. You could also write it that way. Okay? All right, now let's look at example 3, finding equivalent ratios. All right, which of the following ratios are equivalent to 9 to 12? 3 to 4, 2 to 3, 6 to 9, 12 to 16. Let's take a look. Make tables of equivalent ratios. So we had 9 to 12 is our original ratio. If you divide both of those by 3, you get 3 to 4, or 3/4. So that one works. Let's see if any of these other ones work. 9 to 12 was our original. If you multiply them both by 4, you get 12 to 16. So that's also equivalent. If you multiply 3/4, we already proved that one. And then this one is 6 to 8, not 6 to 9. So 6 to 9 will not work. Okay? So 3 to 4, 12 to 16, and 9 to 12 are all equivalent ratios. All right, how about this one? Which of the following ratios are equivalent to 16 to 20? 2 to 3, 4 to 5, 18 to 22, or 20 to 25? Why don't you pause the video here and do that one, and then come back and check your answer. Okay, so 4 to 5 and 20 to 25 are equivalent to 16 to 20. And let's just prove it, okay? 16 to 20. And can I get to 4 to 5? Well, if I divide 16 by 4, I get 4. If I divide 20 by 4, I get 5. So there's my 4 to 5. And how about 20 to 25? Okay, well, let's go to this 4 to 5. If I multiply both of those by 5, I'll get 20 and 25. So they're all equivalent. All right? Okay, let's take a look at the next page. Key concept. You can multiply or divide both terms of a ratio by the same non-zero number to find equivalent ratios. That's what we're really pounding away on this lesson. And they give you a couple of examples here. Multiply both terms by the same non-zero number, and you get an equivalent ratio. Same thing here. Divide both terms by the same non-zero number, and you will get an equivalent ratio. Again, it works exactly the same as fractions. Do you understand? How can you find equivalent ratios? So use one of the strategies that you've learned in the last page and explain how that works. Critique reasoning. Deshawn says that the ratios 3 to 5 and 5 to 7 are equivalent ratios because by adding 2 to both terms of 3 to 5, you get 5 to 7. Is Deshawn correct? Explain. All right, what are 2 ways you can find an equivalent ratio for 12 to 16? What have we been doing? What are 2 ways that you can find equivalence? Okay, and finally, how can you show that the ratios 10 to 4 and 15 to 6 are equivalent? How can you show it? All right, work on those 4 problems, pause the video, and start it up again when you are ready to check your answers. Okay, let's take a look here. All right, so multiply both terms by the same non-zero number. There's a way that you can find equivalent ratios. You could also make a table, but really you're doing that. You're multiplying both terms by the same non-zero number. You could also divide. So if you wrote divide, you're also right. Okay, Deshawn, nope. You don't find equivalent ratios by adding the same or subtracting. It's only by multiplying or dividing. All right, and then for this one, multiply or divide each term by the same non-zero number. Are you sick of me saying that yet? I'm kind of sick of myself, but you're not going to forget it, I bet. Okay, how can you show that the ratios 10 to 4 and 15 to 6 are equivalent? I said reduce them to lowest terms, and it's like fractions, right? So if you take 10 to 4, let's say if you wrote it this way instead of the other way, reduce that to lowest terms. I would divide both by 2, and I would get 5 to 2. And then let's take 15 to 6 and reduce that. I'm going to divide both by 3. And guess what? 5 to 2. They are equivalent. Okay, let's take a look at the other side of that page. Do you know how? Complete the table using multiplication to find ratios that are equivalent to 4 to 5. Okay, using multiplication. So remember, if you multiply both terms by the same non-zero number, you will get equivalent ratios. And this one, you're going to do the same thing, but you're going to use division. See how they set this table up so that this is at the end and you're going backwards because you're dividing. All right, in 7 through 10, write an equivalent ratio for each given ratio. So 12 to 21, what's an equivalent? 1 to 3, give me an equivalent. 6 to 8, find the equivalent. And finally, 15 to 10, give me an equivalent ratio for that one. All right, pause the video here and start it up again when you're ready to check your answers. And here we go. All right, I used multiplication and I came up with 8 to 10, 12 to 15, 400 to 500, just kind of threw that in there for a little something different. Any non-zero number that's the same. You could have 4 million to 5 million. It would be fine as long as it was the same non-zero number. Okay, same thing here, but with division. So I divided by 4 to begin with, and I got 10 to 7. And then for the second one, I divided by 2 and got 20 to 14. As long as you divide them both by the same number, you'll have an equivalent. All right, let's take a look here. So here are the equivalents that I came up with. Yours may be different, but again, as long as you multiply both terms by the same non-zero number, it will be equivalent. All right, so 12 to 21, I wrote 24 to 42, just multiplied them both by 2. 1 to 3, again, I multiplied them both by 2 and got 2 to 6. 6 to 8, this time I divided them both by 2 and got 3 to 4. And 15 to 10, this time I divided them both by 5 and got 3 to 2. Okay? All right. Let's take a look at the next page. Practice and problem solving. Eva is making French toast. Thank you, Eva, for doing a perfectly normal thing. I'm not worried about Eva. She's not, collecting toothpicks and making floor mats out of them or anything weird like that. It's nice to see a kid in a word problem doing something normal. All right, so she's making French toast. How many ounces of milk should Eva use with 10 eggs? Well, let's look here. The recipe calls for 5 ounces of milk for every 2 eggs. So they've started the table there, milk and eggs, 5 to 2, and then they've filled in the part of the ratio that corresponds with the eggs. So then your job is to complete the table for milk. So I want you to do that on your own. And then let's also take a look at 12 through 15. With these, you're going to write 3 ratios that are equivalent to the given ratio. So 3 ratios that are equivalent for each one. All right, why don't you do those problems, 11 through 15, pause the video, and start it up again when you're ready to check your answers. Okay, let's take a look. So for milk, you should have gotten 10, 15, 20, and 25 ounces. Okay, check your work if you got something different. And you can see that with the eggs, they just went in counted by 2s, so doubling each time, and so I just counted by 5s for the milk. Okay, now for these ones, I'll read you mine, but you don't have to have the same as mine. They just have to be equivalent. For 6 to 7, I got 12 to 4, 6 to 2, and 60 to 70. For number 13, I got 18 to 10, 36 to 20, 45 to 25. For 8 to 14, I got 4 to 7, 16 to 28, and 40 to 70. And for number 15, 7 to 9, I got 14 to 18, 28 to 36, and 70 to 90. Notice how sometimes I wrote it with a semicolon and sometimes I wrote it like a fraction. Just a reminder that either of those is okay. All right, let's take a look at the second half of the page. A teacher kept track of what students consumed at a school picnic. That sounds like fun. For 3 grades, the ratios of the amount of water consumed to the amount of fruit juice consumed were equivalent. Complete the table. What a fun picnic, especially for the teacher running around going, how many ounces? How many gallons of water did you consume? Hey, you, how much juice? Okay, so the important information here is for 3 grades, the ratios of the amount of water consumed to the amount of fruit juice consumed were equivalent. That's kind of weird, but okay. So for 5th grade, they consume, for every 6 gallons of water they consumed 7 gallons of juice. Whoa, what's going on with those 6th graders? 24 gallons of water. So how many gallons of juice? And then the 7th graders, 18 gallons of water. How many gallons of juice would that be? Okay. Now remember, they're equivalent. The ratios are equivalent. So your first ratio is 6 to 7. So what did you do to 6 to get it to be 24? You're going to do the same thing to the 7. What did you do to 6 to get it to be 18? And you'll do the same thing to 7. So for every 6 gallons, so that's 4 times that. So 4 times 7 would be 28. Now figure out what the 7th grade is. Let's see. We're going to go back to that 6 to 7 and say, okay, well, 6 times 3 is 18. So 7 times 3 is 21. All right. Let's look at number 17. The attendant at a parking lot compared the number of hybrid vehicles to the total number of vehicles in the lot during a weekend. The ratios for the 3 days were equivalent. Complete the table. Okay, so on Friday, the ratio was 4 to 9. So what are the missing values going to be? Notice with this one, you have to kind of go backwards. This is 4 to 9. So what did you do to 9 to get it to be 63? Do the same thing to 4. With this one, what did you do to 4 to get it to be 32 and do the same thing to 9? I want you to do that one on your own and then try this one too. Shiloh is sharing jelly beans. Okay, Shiloh. The jar of jelly beans has the ratio shown. So 32 green jelly beans and 56 pink jelly beans. I wonder whose job it was to count those. Okay. If Shiloh keeps the ratio the same and gives his friend 7 pink jelly beans, how many green jelly beans should he also share? Oh, for goodness sake. Okay, so we're going to try to ignore how goofy that is. And this is the original ratio, 32 to 56. It's here in the table. So using that same logic, in this case, it looks like you're going to be dividing, find the missing values in that table. So pause the video here, and I want you to do these 2 problems on your own. Start it up again when you're ready to check your answers. Okay, so the attendant at the parking lot. On Saturday, there were 28 hybrids and 63 total cars. On Sunday, there were 32 hybrids and 72 total cars. So that total includes the hybrids. So we've got hybrids and hybrids plus everything else. Okay? Now let's look at Shiloh and his odd little division of jelly beans. Okay. So the original ratio was 32 to 56. And I worked backwards to 4. So half of 32 is 16, half of 16 is 8, and half of 8 is 4. And then I did the exact same thing with the pink jelly beans. So half, half, and half. So 4, 8, and 16, and then 14 and 28 are the missing parts of the table there. Okay. And let's see, the answer then to this particular question is 4. So line up at Shiloh's desk and he will hand out these 7 pink jelly beans and the 4 green jelly beans that he's going to share. I'd rather hang out with Eva, who's just making French toast, but there you have it. Okay, I think, yes, we have one more page today. So let's turn the page. And here we've got use appropriate tools. Don't use inappropriate tools. Okay. Equivalent ratios can be found by extending pairs of rows or columns in a multiplication table. Write 3 ratios equivalent to 2/5 using the multiplication table. Okay, so let's take a look here. If you look at that table, you're looking at 2/5, right? So here's 2/5, 2/5, and then if you follow along on the 2 row and the 5 row, and you match those up, you'll get your equivalents. 4/10, 6/15, 8/20, and so forth. Okay? Now, if 5 miles is basically equal to 8 kilometers, about how many miles would be equal to 50 kilometers? So you're using that kind of ratio thinking again. What's the original ratio in this problem? Yeah, it's 5 to 8. So if you substitute a 50 in for that 8, how many miles are you going to end up with? Okay? Now, vocabulary. How is the word term defined when used to describe a ratio relationship? How is the word term defined in the context of an expression? Do you remember that expression thing? When you have an expression, terms are separated by, do you remember? See if you can remember and answer that one. And let's do this higher order thinking problem too. 3 sisters are saving for a special vacation. The ratio of Ada's savings to Ellie's savings is 7 to 3, and the ratio of Ellie's savings to Jasmine's savings is 3 to 4. Together, all 3 girls have saved $56. Okay, how much has each girl saved? Complete the table. Explain how the table can be used to solve the problem. So with this table, there are several values that are already filled in, and it would help me to write these ratios down. So I'm going to do 7 to 3 and 3 to 4. Okay. So 3 sisters, Ada to Ellie is 7 to 3. Oh yeah, so this is Ada and this is Ellie. And for the second ratio, it's Ellie to Jasmine. Okay. Yeah. All right. So when Ada's savings are $7, we know Ellie's savings are, what's Ada to Ellie? Ellie's savings are 3. Okay, now let's look at this over here. Jasmine's savings, 16 here. So we've got 7, 3, 4. This is 21. 7 something, 21. What do you think? And with this, we've got 3, 6. What do you think the next 2 are? And then with Jasmine's savings, we've got 4, blank, blank. And you'll know you have the right answer when you add these all together and it equals 56. So go ahead and complete the table and then be able to explain how you did it. You can double check your work by making sure that the total equals 56. All right, work on those, pause, and come back when you're ready to check your answers. Okay, so for this one, let's see, my equation, this is the equation I used. I said 5 times 10 equals 50, and then 8 times that would equal 80. So if 5 miles is 8 kilometers, then 50 miles is 80 kilometers. And for this one, term in an expression, each term is separated by a plus or a minus sign. Remember that? And then for terms and ratios, a term is each value. So one part of the ratio and the second part of the ratio, each of those are terms. Okay? So if the ratio is 4 to 10, 4 is one of the terms, 10 is the other term. All right, let's take a look at this one. I filled in the table with, it should be 7, 14, 21, and 28, 3, 6, 9, and 12, and then 4, 8, 12, and 16. And when you add all of those together, you get 56. And Ellie and Jasmine had better pick up the pace or they're not going anywhere, right? Okay, what I did was I increased each by the original amount saved or multiplied each original amount by 4. Okay, to get to the last number. All right, now let's look at assessment practice. Select all the ratios that are equivalent to 18 to 8. And then for this one, select all the ratios that are equivalent to 3 to 5. I think we've done this enough now. Test them out, find your equivalents, and you should be able to do those. So pause the video here. Remember, you're either going to divide or multiply by the same number, and you'll find equivalents. So start it up again when you have solved those two. Okay, so for 18 to 8, 9 to 4 is equivalent, 90 to 40 is equivalent, and 36 to 16 are equivalent. Do you see, if you divide them both by 2, you get 9 to 4. If you then multiply them both by 5, you get 90 to 40. And if you just multiply them both by 2, you'd get 36 to 16. For 24, select all the ratios that are equivalent, 3 to 5, 9 to 15, multiply them both by 3, 18 to 30, multiply them both by 6. All right? Okay. Good job today. Hope that's all making sense and your fraction skills are helping you out. I will see you next time. Bye.